There we go. All right, welcome folks to our second honors program colloquium of the spring 2023 semester. My name is Craig McCashin. I'm the director of the academic honors program here at A&M-Texarkana, and it is my great pleasure to introduce my colleague, Dr. Nelson Irizarry, assistant professor of mechanical engineering, who will be speaking to us today on management and ethics in engineering. So after the talk, there will be an opportunity for some questions. And yeah, take it away, Dr. Irizarry.
All right,
I'll get out of the way.
good afternoon, everybody. Let me just share my screen here if I can get this going. All right, can everybody see it online? Or
I don't know that it's shared, actually.
I'll tell you what, we'll
You have to do it through Zoom, yeah.
okay, let's share.
Yeah, share.
Where are you at? There you are.
There it is. Okay. Now we're good. That is the telltale Zoom level.
All right. So good afternoon again. I'm Nelson Irizarry, assistant professor of mechanical engineering. One of the topics that I've been debating about and thinking about a lot for the past 3-4 years is the concept of ethics within engineering. And I even took the liberty of bringing quite a few magazines from different engineering organizations around the US. And all of them make a point in every edition to have a section dedicated just to ethics. And usually is the ugly. Who did what, where, and when, and why, and how it was handled. One thing that stood out to me was that it has to do a lot with what I call leadership. We put a lot of emphasis on management, but the leadership aspect for engineering kind of goes on the side. Nobody even mentioned it for that matter. So my objective today is to kind of talk about what leadership is within engineering and how we can bring it back where it should be as part of our curriculum. So as our engineers graduate, perhaps they're better prepared to handle ethical dilemmas and so on that they will face. In engineering, we're subject to a code of ethics. And this is the one from the National Society of Professional Engineers. Every association in engineering has one. They're very similar to this one. But it strikes me that as you read a lot of these cases, where they fail, where the engineers fail, I think that, lo and behold, seem to be in style these days, honesty, impartiality, fairness, equity. And you look at the cases like, how could somebody get to that level and not realize that this is kind of, I'm going to call it common sense, that you have to be, fair in your assessment, and that you have a duty to protect public health, safety, and welfare. And you have to, no matter if you're licensed or not, the moment you graduate with an engineering degree, you have to adhere to the highest principle of ethical conduct. Though it seems like if you're not a PE, everybody else forget, or I'm not say forget about it, but there's no emphasis on it. So who's an engineer? Professional, we invent, we solve problems, we fulfill a need, and we do that with certain constraints of the money, so much money is available. It could be, depending on what you're designing, it could be space, it could be environmental constraints, legal, regulatory. So most people think of an engineer as a technical guru, a guy who just those numbers and try to meet those. But the engineer is a lot more than that. It starts when you get your degree. You've got to have a degree. And to certain standards in the US, the common standards, the Board of Engineering and Technology, and they come and accredit your university, and that says that you meet certain requirements. One of which is ethics. And I'll say this here because it's true. We don't have a single class dedicated to ethics in our engineering curriculum. We cover it, bits and pieces in elective courses. So if you don't take it, you're pretty much out of luck. I do cover it in project management, but electrical engineering doesn't take project management. So it's a decentralized approach, and it's kind of luck of the draw if you get it or not. But one thing that I highlighted in red is that engineers are required, should be required to take continuing educations, and one of those requirements is ethical component. Unless you are a guy like me who's got a license, nobody enforces it. There's nobody to enforce that you stay up to date on, not even in continuing education, but definitely not in any kind of class in ethical behavior. I'm required every year to take those courses. I'm required to take ethical class every year. Again, why? Because at the level when you call yourself a professional engineer, there's no option. You have to do it because, or else you lose your license. This field, that's mine right there. I bet, it's an old one I had. You get it every so many years because you got to change the date on it. It comes with a level of experience. So you can't call yourself a professional engineer. In some jurisdictions, you cannot even call yourself an engineer unless you have a professional engineering license. It's in, and I'll say because I'm from Puerto Rico, and Puerto Rico is against the law. Graduates from our engineering school are graduates from an engineering school. And when you complete the engineering training exam, you are engineering trained. You cannot, again, it's against the law, and it's punishable with pretty funny fines and stuff if you do it. But part of it is there's an account, this part right here, and mostly in the ethical side, there's an enforcement. If you do not comply with some rules of ethical behavior, not only you lose your license, in some cases you can go to jail. And, when I was a student, I kind of thought, well, that's ridiculous. I mean, I know what to do. I'm an ethical kind of guy. My mom taught me well.
What about your
But
dad?
I don't know about that one. Actually, I did learn a lot from my dad regarding ethics. Some of it by force. But much like a doctor or an attorney, once you get to that level, you have to, you can't call yourself an attorney unless you pass the bar exam. But engineer, again, most jurisdictions can. I'm an engineer, I can go to work and I can make tons of money. Hopefully. But the reason why a lot of these jurisdictions, and I use Puerto Rico perhaps being the most extreme, and I've seen the same in Spain, is because you have a responsibility to society. What we do, what we come up with, what we design, what we invent, health, safety, and welfare. I can't just say, I'm an engineer, I'm going to build a bridge. And, I put a couple of sticks together, super glue, duct tape it. Of course, it's going to fall. Nothing happens. No. A guy like me, once you get that little number, I can go to jail. I'm completely liable for anything that goes right or wrong about that problem. Usually what goes wrong. Because it's my duty to protect the public welfare above all. So you come to me and you tell me, hey, Nelson, can you cut a little corner here? So we can save some money. Nothing's going to happen. It's all right. No, I can't. So in some situations, I tend to be very vocal, even if I'm not the engineering designing something, because I know this is my obligation. Even if I'm not in charge of the project, I'll make sure my voice is heard. And I'll put it in writing if possible. So when it goes south, and some equipment goes to the floor of a new building, you can say, I told you so, and I'll be the first one going, raising my hand in front of my judge to say, yep, I told him on this day it was gonna happen. It's part of our, I mean, when you accept this responsibility, and again, a lot of people don't understand it, especially, I try to reinforce it to students. It's a big responsibility. People can die. I mean, that's the end of it. And we are 100% accountable for everything we sign and we put our seal. And that, like I said, that not only money-wise, but it could include going to jail. So that's an engineer. The guy who's accountable, invents, does all this stuff. But there's more to it. And this is the extra part that we don't talk about. An engineer has to be a leader. I can't just sit back and say, hey, somebody else will take care of the project. I have to be a leader. And by leader, it's in the most general concept of what we do. But the most important thing about the leader, I'm accountable. I should know what's right by the time I graduate. Time I walk through that parking and I go home, I should know what's right and wrong. If I never knew, at that moment I should know. What we see is that most engineers, especially those graduates, you're gonna be a manager. And it's great that you're a manager. I mean, I've done it for smallest project to the largest project. But there's a difference between the two. And there's a tendency, especially in governmental structures, that if you have a title, that makes you a leader. Or because I sit in an office in certain high-level floor, I'm a leader. And that ain't true. Same way, you're in the same floor, Craig. So we're gonna, okay.
That was my
I said higher level.
I know.
So if you are a manager, same thing. You can have a title, doesn't mean you know how to manage it. You can have all the friends in the world and get all the titles you want. I'm not going to go into politics. They all call themselves leaders. I have questions about that. But both are live within this framework of ethics. And we need to reinforce it. This is a combination of my experience as engineer in the government, government and private sector, and also a lot of my experience in the military. When I talk about a leader, these are guys who make decisions usually. They're not sit back and wait for somebody to tell them what to do. And if there's nobody around, they take charge. So when I think of an engineer, the designer, the innovator, they're leaders. They're given a basic set of guidelines, and they come up with a vision, and then they turn to their team. And one thing about leaders is they work in teams, and usually they surround themselves with people who are better than them, and they just provide direction. Said, now we're going to go this way, guys. Make it happen. They don't stand in your way. They don't micromanage. They don't have 300 meetings every 5 seconds to discuss the stuff that was discussed the last week. They do what's right. And in the engineering world, that means your designs are solid. You meet all the guidelines. You check every block up to that moment. I mean, laws can change later, but up to the moment you're in, you know that what you're doing meets all the safety requirements. You protected the welfare of people, and you're doing the job, again, to the best of your ability at that moment. And you can go home and say, I got nothing to worry about. Now, that doesn't mean that everything you design is, beyond failure. There are things that we call acts of God that could destroy your plans, but those are above your level. I mean, things happen. But as long as you try, within a good solid background of doing the right thing, you're fine. You always take responsibility or liability. You don't have to wait for anybody to tell you. You accept it. You make a mistake. You forget something. I forgot. My bad. Let's redo it. You don't go somebody else. Can you cover for me? Because you forgot. And come up with 300 stories. You hold those below you account. There's no question about it. I love you like a brother, but if you did it wrong, you did it wrong. Now, it doesn't mean I'm gonna fire you, but there'll be a consequence, and it ain't gonna be, oh, well, don't do it again. Maybe if you do the coffee wrong, I'll say, don't, you can try it again. But what we do has consequences. So if you do it wrong, I can't go back. I mean, I gotta hold you accountable. We believe in teams, and I use the example of the Skunk Works, the group in Lockheed in 1943 that were charged. Here comes the department. Well, in those days, the Department of the Army says, "Hey, the Germans got something that goes really fast up in the sky. We're going to call it a jet. We don't have anything like that. Can you guys do something?" And this Skunk Works was organized. A bunch of engineers, one guy in charge, a leader, and we did 143 days. That's pretty short span of time, especially in war. They come up with a solution, a jet that actually worked. By the time, and they were all just asked to design. By the time it was manufactured, the war was over. But they did their part, and they continued the Skunk Works for a long time. They, I don't know, familiar with aviation, but they designed the SR-71, the fastest plane ever, that has all the world records and flies way up there. Now we don't fly anymore, but if you ever have a time to go to a museum, you'll probably see one in Washington, D.C. There's one in Dulles Airport. It was a team of engineers, one guy in charge, make it happen. A lot of respect, a lot of understanding among themselves, allow them to, again, design some of the most remarkable aircraft we've ever had. I use that term, I got that in the Army, the leader knows where the rubber meets the road. You can't see it in the highest floor of your building. Never come out, never look at your, I want to say subordinates, or the people who work for you, if you're an engineer, all the way to the guy, the machinist. You never see him and expect to have a meeting, have them all sit around, and then they're going to be all sympathetic and tell you everything that's going on. And no, it ain't going to happen. You have to go to them. You got to know where they live. You got to know how they live, what their predicament is. In the lab, do they have space or not? You got to know. You can't rely on just not to say that people will lie to you. People will provide information that they think you want to know. Not necessarily the whole truth. You're fully aware of the cultural, societal, and all that stuff. And I have plenty of examples of engineering we can talk later, where engineers were not aware, especially culture, and came up with the worst designs ever. From the engineering point of view, awesome design. Awesome. Completely out of place and out of context. And in some cases, were demolished because the people don't want them. That's just the way it is. So, we don't teach this. That's a problem. We don't talk about this. Well, I do in class. But if you don't have class with me, you never know what that is. So you do what's right. Now, let me take you to the manager, which is what we talk more about. I teach project management here. The guy who executes. Make things happen, organize it, got a big chart like that, has meetings and looks important. Hey, we're gonna meet the deadline or not. We're 3 pennies over budget, somebody's gotta be fired. We're gonna have a flat budget because we can't do this. So, and that guy, usually the manager just follows regulations and laws. It says here that I will have a cap on this. And he's going to have it. Sometimes they seek to optimize, and if they're not familiar with what they're working with, they optimize to the point of absurdity. And that could be a problem. And they rely on the team. They rely on it, they work with it, if they're good managers, again, they surround with people better than them, and they make the thing happen. The leader does the right thing, managers does things right. So the leader tells the managers, hey, these are the right things we need to do. Manager says, got it. I'm going to move and do those things right in accordance with all regulations. So an engineer can do both. And in a lot of times, especially the older you get in the profession, the more experience, you find yourself where you're doing both. And you kind of go from manager more to the leadership role as you climb up the corporate ladder or your own company. And you see managers very eager. Boss, how do we get? I used to ask some of my subordinates when I was managing construction projects, facility. I got it. Everybody says no. How do I get to yes? How do I get to yes? Legally, ethically, morally correct. How do we do it? And that's when you challenge them and they come back. Usually a very creative solution. A good manager is not afraid to fire people. It's all right. It happens. You can fire them. And to say no. No, it ain't happening. But with all that said, my concern, again, from looking at, and again, this comes from every month for the past 3 or 4 months, is that these guys, the most typical ethical violation, I just took a little bribe, $200,000, whatever. It's just, kickback, whatever you want to call it. And these, I don't say these, American Society of Civil Engineers said this is the latest trend. This is what we're seeing, that the project manager, particularly in the government, are very prone to take kickbacks because, money's not, great. I work for the government, and, I need to buy me a new car or new tennis shoes, whatever. So we need to emphasize for both, for the engineer as a whole, the complete engineer that can do leadership, they can be a leader, can be a manager. We need to make sure they understand the ethical dilemmas you're going to face. And, go back to ethics. And that's not even all the associations and organizations that cover engineering. All of them have a code of ethics, 100%. They just tell you right versus wrong. You should have that core values that you either gave to your family or usually the family, where you grew up, your culture. There's some things that we know that are wrong. You don't kill. You don't kill a human being. Generally, you can say there's certain things you don't steal. That at least where I grew up, that was, if I did, I would not be here standing today. There's some core values, but then the code of ethics just take it to the next level and kind of explain it, breaks it down for you. And I took, these are from some of those cases that I've been reading and other literature. I call it significant ethical red flag comments. You hear these from, and these are from engineers, some of how they start their argument to defend themselves when they're accused of ethical violation. Now, if you're familiar with some of these, please, I had no choice. Otherwise, I might have been fired and not my promotion. I was coerced into it. I can't help it. Yeah, I took $200,000, but they made me. I can't. I had to give the contract to Billy because I worked for a politician and he said I needed to do it. He ain't gonna save you. I was told to do it. The most typical one. And you do that a lot with managers. We have always done it that way. Everybody's heard that. We've always done it that way. And there was never a problem. There was never a problem till somebody got killed or somebody got injured or there was a significant loss of property. That's typical in the government, and I worked there for a while, and you see that all the time. It makes no difference, I have to say government, because well, it makes no difference if you do that or not. I mean, when was the last time we had a hurricane category 5 around here? Come on, it'll be fine. 2 weeks later, you get the hurricane category 5. Let's move on. Let's just forget about that. Yeah, we didn't use the right steel, but it's all right. I'll give you an example. This is true. I was managing a project in Germany for the Department of Defense. And the law says you cannot buy steel from any other country but the US for those kind of projects. I don't know who came up with the law. Somebody in Congress. I tend to agree with it. But when I get a shipment in Germany of tons and tons and tons of steel that it doesn't take. To the untrained eye, they may know where it comes from, but every rebar has got a certain code, and you know where it's manufactured and everything. And it's China, and I'm told, and I go and verify, I say, you're right. I love my brothers up there, but I can't accept it. It would be an ethical violation because I know it. Now you can tell I didn't know, and perhaps you don't know, but it's my job to know because I'm the guy with that seal. I'm the engineer. I should know. Therefore, you take all that nice steel, melt it, send it somewhere, sink it in the Atlantic Ocean. I don't know, but you ain't using it for this project. And that's when you become the most hated guy in all of Europe. But it's a matter of ethics. It's the law for crying out loud. And I'm not going to put myself in that position. This is one that is very typical. The Secretary of Misleading Act or statement to protect your position through, I'm not going to say falsifying reports. I say you're kind of selective of what you write in the report or the statement that lead to a false conclusion. So you see these a lot with environmental documents where, it's just a little bit above the legal limit. We're dumping stuff from Red River. I never said that. And it's going to a body of water. And I know that it meets the requirements within, well, I'm gonna call it within the fence. But I do know that we've measured it outside the fence and it doesn't. But you know what? It's all right. So, they may kill a couple cows here and there or something. Just lay flat. You can. And people do it. Why? Because a lot of times the statement comes because they did something wrong before.
How often does this happen?
Quite often. Sadly, quite often. Quite often, and you see it a lot because, I'm not going to try to make an excuse, but we hire, and this is through our government and private sector, we have quite abundance of engineers who just graduate. And they go out there and they get a quick training. They've never been under a professional engineer because there's only one in the company. So a lot of times they just hang out with the techs. And I'm not blaming the techs or anything. They just fall through the cracks. And they think you hear that, don't worry, it's all right. We've done it before. Nobody's going to find out. And the poor engineer just graduated, says, okay, you said it's okay. You've been here 30 years. Yeah, but he ain't the engineer anymore. And you say, yeah, it's over.
So where are the checks and balances?
Checks and balances should come internally in the company. And again, I'm going to give you the extreme check and balance. And I use Puerto Rico as the extreme check and balance. You cannot, you have and I was head of this government agency that verifies each and every plan or design that is done on the island to verify that they're signed and sealed by a professional engineer. Because if something goes wrong, I got somebody to send to jail. Then, during the process of construction, two options. I can send somebody from the agency, or I don't know, you're a professional engineer. You go and check it out, but then you certify that you checked it properly. So when it falls, I got another guy who's go check. So that's kind of a check and balance down there. Down here, depending where if you're in city limits, a lot of times, you know, you got the guys from the different, you know, Texarkana for sure have usually in the planning board, there's a little agency that goes and checks permits and everything, construction and everything. You need the separation from the other building, that kind of stuff. Do they go into the detail of seeing what's in the plans? It varies. If you're in California, you bet you they do, because of the earthquakes and that kind of stuff. So places that are prone to a lot of, and I'm from the civil engineering perspective. Florida, Puerto Rico, California, you're going to see a lot of that. I mean, they're magnifying glass in public. In other places, perhaps Arkansas, where I live. If you're not in Little Rock or Fayetteville, you're part of the US, that's what we know. And you know, nobody checks. Even the counties don't check what's going on in construction. Now, when you go into the private sector and, you know, our mechanical engineers are designing something, manufacturing here, any other plants, it's up to the professional engineer in the company to verify and sign it somehow. I'm not going to tell some of the horror stories here with students, and build it, and let's hope that it does not fall and kill somebody. And I had the incident the other day with a group of senior design students. They were, I want to say, refurbishing, making a new design for a little conveyor thing. They did everything right. Till they mentioned to me, oh, and I said, well, how do you power that? Oh, they have all these really nice old dilapidated batteries in series, and they just charge them with this cable and about our I said, no. I could have said, oh, well, that's not part of your scope of your project. Have a good one. Now, the right answer was, no. This is what you're going to recommend, and you let them know that what they have is a safety hazard, somebody's going to get hurt. And please write that I said it on this day. I write a little memo for record. So if it happens, I told somebody. But anyway, so this happens sadly often. I mean, there's a case I'm following now in Puerto Rico. Perfect design. It's an American company that did a perfect design for a cable stay bridge. The construction company, super reputable. I mean, they knew what they were doing, but the actual guys on the ground putting it together, I'm going to call it, they decided that for some odd reason, but I don't know why, it was a cool thing to mix with concrete. All the extra paper and I'm going to call beer cans and everything that was out there, it was a garbage. Just throw it in the concrete. It's all good. Bridge is there. Nobody can ride over it. We found out. And now it's probably going to have to be demolished. Both the construction company, they're going to go after the designer. I don't think they're going to get to the designer, but the construction company, they're going on. They're liable. The case in Memphis with the bridge, where the inspector, well, I kind of, did you actually inspect to see if there were cracks? Well, I took a peek. When? Well, this time, he had falsified documents, said he had done it and did it. I mean, luckily nobody got injured, but it could have been a major catastrophe. So we got all that. And this one, ethical problem magnets. And these are the guys that sadly we find in the practice. And I guess my goal is to prevent from finding any of these guys. Again, if they're familiar to you, I'm sorry, the money hand you got. I'll do anything for money. Don't matter. You bring the money, I got you. You want me to get rid of half the material? Not a problem. It's a little corner. It's all right. And they'll take kickbacks, bribes, whatever. I mean, these are dangerous guys. Then you got the people pleaser. These guys are usually scared of their own shadow. Because sadly, they have limited experience. And that cannot explain what's going on at any one point. So what they do is, they give you lines like, we're evaluating, we will implement a method in the future, we're gonna plan to plan the plan. Nothing happens. But these guys, why these guys are a problem in terms ethically for the engineering practice, they're not leaders. You know, in the army, we used to call them speed bumps. You know, they're not allowing me to move fast enough. And what's happening is they fall, they're easy prey, usually to the money hungry guy, or somebody else who takes advantage of them. Hey, you know what? I'll take care of this. Don't worry about it. I got this. Oh, you're so nice. That is so great. You're the best guy in the company. And a lot of times they even put papers for them to sign. Of course, they walk out, they don't go to jail. The people pleaser goes to jail. And my favorite, the yes man. Agrees with everything, even if it's wrong. Yeah, I'm your guy. That's absolutely great design. Yeah, but it's held by duct tape. It's great. Usually they're looking for recognition, and otherwise they may not get. They like promotions, positions, titles, special projects, because that makes them feel important. But again, if you put one of these guys in charge of it, you know, in a true leadership position or in charge of a team, failure is going to happen. And that's one of the things that I emphasize in my courses when I do in the labs and the project management teams. Everybody's going to take a chance at it. I'm going to evaluate you, and I'm going to see if you're one of those. And then your peers are going to evaluate you and see if you're one of those guys. Are you the guys who are just trying to please me, make me feel happy because you did it on time? But in fact, I know you went and had somebody else do it for you. I mean, we need to somehow bring this into the classroom. And you know, I know I'm running short on time, so I'm going to go through this, some tools and indicators that are used by I'm going to say successful leaders, especially if they have high ethical standards. The team, you know, leaders and managers, the most effective tool you can have is there's a leader in charge, somebody in charge, please. You know, because you go there, if you just go there and have a gathering of the minds, nobody can make a decision at the end of the day. You're going to be meeting every week, you know, and then don't get offended. The community doesn't exist in engineering. We don't. I don't teach it. I don't. Now, if you have a committee in engineering, something is wrong.
Oh.
And by that, I mean in an engineering firm or the government, an agency that is actually doing engineering. Now, in academia, we're different. And I will say that in academia, there's no requirement for the professors to be professional engineers or to have a level of experience. You can graduate with a PhD, 3 PhDs, and come and be a professor. There's no requirement, not in the US. Big deal. I don't even think we require. I try to get it to be listed as preferred requirement in our, but I got overruled. So the tool is low, it recommends. You're gonna like this one. This is why we don't do it. I love this guy. A camel is a horse designed by a community. Communities in engineering tend to, because there's no, again, I'm talking in the engineering firms or a big company. They can never get to a decision. And you're limited usually by time. And what you end up, you say, design me a horse. You end up with a camel. Great animal. But I need speed. I don't need you to be able to hold water for, 300 years. This guy who's the designer, I can't say it. Somebody speaks French better than I do. He's the lead designer, lead designer of the Mini Cooper. He was trying to get something to compete with the Volkswagen Beetle. Small, cheap, fuel efficient. And he got a bunch of cans.
Bold statement, the guy that made the Mini Cooper, though, to be fair.
Yeah, and he finally says, I don't need a camel, dude. I need something with four wheels, stick shift, steering wheel, maybe a speedometer. And that's what he got. The over engineering, overthinking made him say this. So if you're working with me or for me ever, you'll never hear me say the word committee. I'll be talking teams and all day long. Then this one, of course, I know you're not familiar with, but I use it as an indicator of a problem with leadership. When the company, especially big companies in the government, you start hearing a lot of, let's have a town hall meeting. Let's have a sensing session. That means that the leader is in whatever floor and never saw what was going on. And to try to correct it at last minute. Engineers need to know what's going on the manufacturing floor before it's too late and the quality is poor. They should be that first line of defense. And that's what I tell my students. I don't need you in an office. You go to the office. I need you on the floor checking what's being manufactured. Then when you have meetings that never end, if you have a problem with management, and you see the same agenda over, and over, that's management. That ain't leadership. I think you just don't know how to manage your time. Again, I tell my guys, don't call a meeting unless it's required. If you don't need it, it's all good. Assume that everybody knows what they're doing. Because if they're not doing what they need to do, what did I say about the manager? They're fired. They fire people, and they enjoy it sometimes. So, bottom line, for the engineers, and then again, in education, we need to differentiate this for the kids, for the students. They need to know the difference, and how ethics frames what they do. We need to teach it, make it an integral part of our curriculum somehow. They need to understand, basic concepts of integrity, honor, and dignity. It's just, again, you read what's going on in all the magazines, and it's sad. A lot of these kids are young and they find themselves in big trouble. I'll dare to say, and I'll leave you with this one, we need more engineering leaders with managerial capabilities that can lead teams versus a bunch of managers who can't even sometimes get a hold of the team. So enough said. Open to your questions. I got plenty of horror stories to tell you about and funny ones. If you got questions about anything from bribes to you name it. Yeah.
I do not have a question about bribes. But so you mentioned the importance of an environment. So if you are applying an ethical code of conduct to a stable environment, that seems to me pretty black and white. But what happens when the environment shifts, right? So when safety codes change, when requirements change, so the environment has changed. At what point does a sort of ethical responsibility change hands from the project leader at the time the thing was finished to coming back 10 years later, for example, when hurricane proofing codes might change?
Right. So, great question. You're liable or responsible for what was up to date at that moment. At the moment it was designed and built. What we see a lot of times is that, especially in government projects, is that it's designed, but because the procurement process in the government is so long, especially if it's congressional money, which is what happened in this case. I was talking about Germany. The project was designed, I think it was like 6 years before I got there. But to get the money from Congress took all that time. So the money shows up. All these rules have changed that I have to enforce now in construction. And people are like, no, I have to enforce it. Now, the design was still within the allowable limits and so on, with the safety factors and so on. So you're liable only for what at the moment you build it. Now, I will argue that if I'm a responsible engineer and I know there's been a significant change and I'm still alive, and I did something on their own code, I probably should tell somebody, hey, I designed that. It happened this a lot in the late 80s. We did a major change in design with steel in the US. And we went from one method to another. during that period, yeah, they could have gotten away with the old method. Because I didn't want to do the new one because it was more complicated. But if I had designed something recently, I would have gone back and said, hey, listen, that. Just to remind you, I designed this under these conditions. That bridge would not pass with the new standards. Now, I'm not liable, but I'm saving my responsibility, if nothing else, my good name. You know, my dad and just about everybody I have holding high respect that I've worked with, you know, the appearance of impropriety is just as bad as being inappropriate. Not a lot of people, you know, agree with that. But in engineering, your name is everything. You know, your name, your reputation. If you are the guy who's responsible, who turns your project on time, who's fair, who's responsible with the environment, the communities, that carries you a long way. I mean, you make a lot of good friends just by doing that, keeping your good name.
Any other last comments before we free Dr. Irizarry?
Well, I was gonna say, I agree with teaching that. I worked in the restaurant world for 16 years, and I cannot tell you how many managers have come through, but there are very, very few leaders that showed up and really were true to what they believe in, don't know anything about the company, but just took over.
Just the care.
Mhm.
Yeah, just you know, I've been in places where I had no clue of half the stuff I was doing. In 2000, I was assigned, call it the lead engineer for the island. And I worked already for the government. Yeah, I knew my area of expertise. But power, all that other stuff, infrastructure agencies, I don't know, I know I can switch the lights on and off.
Yeah, maybe.
But spending time there, that makes a big difference. And you earn the respect. And then they teach you. You learn a lot from going down there. You learn, and as an engineer, you gotta be willing to learn from everybody. You know, the PhD is not our final terminal degree. It is on paper, but you gotta keep on learning every day. That's what is a requirement, continuing education, except in academia, we're not required to do that. Or take ethical.
All right, any other last comments? Otherwise, let's say thank you to Dr. Irizarry. We'll back a little bit. And I will go ahead and get this up on our YouTube channel for those of you who want to watch it again. And then our next colloquium will be March 22nd, where Jennifer Lopez, one of our honors students, will be presenting on some work she's been doing. I believe this one is with Dr. Minton. I'll have to double check, but I'll send something out after spring break. So take care, folks.